Hello guys, so we are back again, and in this session we are going to do some more questions on chain rule. In the previous video we have covered uh, three questions, okay, which were on the basis of that a middle term we have to assume and then we have to solve, right, if you remember properly. So in the new section we are going to see some more varieties, okay, and probably the next session will be the last session on chain rule. So before beginning with the questions, hope you have subscribed the channel and don't forget to share it with your friends so that we can bring more engineering content to you guys. So with that said, let's begin with our questions. So the first question which we are going to do is this question, right? The question says if x square equals to au plus bv and y square is equals to au minus bv, show that x dou z by dou x plus y dou z by dou y and 2 into u dou z by dou u plus v into dou z by dou v. We have to draw the graph. How we will draw the graph? The graph will be like this. First you have to identify the central function, which is z. Okay, what are the middle functions? The middle functions are x and y. If you have, so drawing the chart is very important in itself. If you are not able to draw the chart, this tree diagram, then your answer, okay, will get wrong. So here it splits into two things, u and v, as you can see. This also splits into u and v, as you can see. Okay, just so after drawing this chart, the probability of getting the right answer increases. And you don't have to show this graph on the paper, okay. Instead what you will do, you will show this x square is equals to au plus bv. So but we require x, so x is equals to what? Under root au plus bv. Similarly y square is equals to au minus bv. So what we are going to do, we require y, so we are going to take y, which is au minus bv. Now we know we will go from dou z by dou u, and here from dou z to dou v, and dou z by dou v, and dou z and dou u, like this. So we can get this value. So we are going to prove it from RHS side. Okay, why we are not going to prove it from LHS side? Because we cannot get dou z by dou x, which is the intermediate value. Okay, hope you can understand this thing. After solving so many problems, you will automatically come to know these small things. So you have to represent this graph how x is a function of x comma y. Then you can say x comma y is a function of u and v, right? Further on, you can say by chain rule, what you can say? You can say dou z by dou u is nothing but dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u, right? After this, what we can do? After this we can do one thing. So let's get the values with respect to u. So dou x by dou u will be nothing but dou by dou u, substituting this value au plus bv, which will be nothing but twice under root au plus bv, right, into a. Hope you have understand this step, how we are getting a, because this is u, sorry, this is u, so we will differentiate this one by chain rule, so it will become a. Similarly, dou y by dou u will be dou by dou u under root au minus bv, which you will see is coming out 2 under root au minus bv, which if you simplify you will come to know this a only. But under root au plus bv, you have said it is equal to x, so I can write it 2x. Similarly here I can write it a by 2y. So I am getting these values of dou u by dou y by dou u and dou x by dou u. So what I'm going to get, I'm going to substitute in this equation to get dou z by dou u, which will be dou z by dou x into this value, which is nothing but a by 2x, plus dou y by dou z by dou y into dou y by dou u value. I have a by 2y, right? So what I'm going to do after this is do one thing, take a common. Okay, why? Okay, if you observe the proof, here u is there, so multiply throughout by u. So if I multiply, I'm going to get dou z by dou u times u. Here I'm going to get u times dou z by dou x a by 2x, plus if I multiply here I'm going to get u a by 2y dou z by dou y, right? So we are done with this thing. After this, what we are going to do, call it as some a. In the next step, what we are going to do is by chain rule, similarly what we can get dou z by dou v, which will be what, by chain rule, dou z by dou x into dou x by dou v. Dou x by dou v will be nothing but 1 by 2 under root au plus bv the whole upon b, where under root au plus bv I can write replace by x. So it will be nothing but b by 2 times x plus dou z by dou y into dou y by dou v will be what? It will be 1 by 2 under root au minus bv the whole upon minus b. So it will be twice y minus b, if you can observe. So what I'm getting finally is dou z by dou x b by 2x minus dou z by dou y b by 2y. If you observe clearly, you will come to know it is dou z by dou v. You can call it as a. Sorry, you have already called something. No, you don't need to call. First multiply throughout by v. So by v. So if you multiply dz by dv will be vb by 2x into dou z by dou x minus vb by 2y dou z by dou y. You can observe it clearly. Now we will call it as some b. Now our next aim is what? Add a plus b. What we are going to get? U dou z by dou u plus v dou z by dou v, right? If I add them, dou z by dou x is similar, so what I am getting is 2x by au plus bv into dou z by dou x. One thing. Second thing is 2y au minus bv into dou z by dou y. Before multiplying it throughout by 2, okay, let's now multiply. Okay, let's multiply throughout by 2. If I do that, I will get twice u dou z by dou u plus v dou z by dou v, which will be au plus bv by x into dou z by dou x plus au minus bv by y into dou z by dou y. So we are getting this thing. Now you can clearly see au plus bv is nothing but x square. So I will substitute. Similarly, au minus b is y square. So if I substitute x square by x into dou z by dou x plus y square by y into dou z by dou y, you can say this will cancel out. I'm getting x dou z by dou x and y dou z by dou y. So we are done with this problem. Hope you have understand each and every step of this problem. Now let's move on to the next question. Okay guys, so the next question which we are going to take is this question. The next question is this: if z equals to f of x comma y, where x equals to eu cos v comma y equals to eu sin v, prove that first x into dou z by dou v plus y into dou z by dou u equals to 2 power e power 2u into dou z by dou y. First thing. Second is dou z by dou x the whole square plus dou z by dou y the whole square equals to e power minus 2u into dou z by dou u the whole square plus dou z by dou v the whole square, the whole bracket. Now whatever we need to prove, first we need to get the chart ready. After that we will decide, okay, from right hand side or left hand side we have to proceed, and then okay, we will proceed and get some main things. So let's draw the chart. I know from make out that z is my main function. I can make out that it is a function of x comma y, firstly. Second, x and y are function of u and v, right? Now what we can see here is one thing. If we observe clearly, you will come to know one thing. First write the things which are given, then we will discuss what you can see. Eu cos v, y equals to eu sin v. Okay, you have wrote this, write it as well. So the thing you can observe that here dou z by dou u and dou z by dou v, dou z by dou u and dou z by dou v are the main values, and we can get those values first ready, and then we will proceed for checking the proofs. So before beginning, let's show what the function is. It is a function of x comma y, then it is a function of u comma v. In box bracket also it is fine, no matter. So what we are going to do, by chain rule, what we are going to get, dou z by dou u is nothing but dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. Firstly, one thing. Second thing which we are going to proceed with is dou x by dou u. Dou x by dou u, I can get dou x by dou u is nothing but, if you differentiate it, you are going to get eu cos v only, because you are partially differentiating x with respect to u, and if you differentiate y with respect to u, you will get dou by, I forgot to write the intermediate step which was this, which is eu sin v only. So we are getting both the things. Let's substitute dou z by dou u is equals to this thing which is x dou z by dou x, and this thing which is y dou z by dou y. Just call it a, because I want to get my dou z by dou u and dou z by dou v ready. By chain rule, similarly I can say that dou z by dou v is nothing but dou z by dou x into dou x by dou v. What I can write, dou x by dou v. Dou x by dou v is nothing but minus eu sin v. And dou z by dou y into dou y by dou v, which we can write as eu cos v. If you observe, this is nothing but it is minus y, so we will get this value. This is y, with minus sign will become minus y, and this is eu cos v, which is x. So minus y dou z by dou x plus y dou z by dou y. If I add both of them and multiply, okay, let's substitute the values in one, or let's multiply. Okay, it's up to you. Here we forgot to multiply this thing. Let's call it b. So we are going to mention here multiply a by a by y and b by x, and add them. So what we are going to get is x dou z by dou v plus y dou z by dou u, if you observe clearly, right? We are going to get this thing only. And if I substitute the value dou z by dou u, dou z by dou e is multiplied by x, it will become minus xy dou z by dou x plus xy dou z by dou y. Similarly, here I have put some wrong thing or what? EU cos b, it was x, right? I have put it y. That is the mistake. It will become x square. Now this is what, this is multiplied by y, which will be xy dou z by dou x plus y square dou z by dou y. You can clearly see this and this will cancel out. We are left with x square plus y square into dou z by dou u, dou z by dou y. So we are getting this thing. Now what we can do, x square is what? X square is e power 2u cos square v, and it is e square 2u sin square v into dou z by dou y. E power 2u, I will take common, cos v plus sin square v will automatically become 1. So this is nothing but e power 2u dou z by dou y. So we are done with this thing. I will call it, okay, doesn't matter whatever you call it, but we have proved what they wanted, that e power 2u into dou z by dou y is this. So we have proved, hence proved. Now let's move with the second thing, which is, we will move with this part. We will square the square a and b and add them. So if I do that, I'm going to get what, dou z by dou u the whole square plus dou z by dou v the whole square, which is nothing but what we are going to get. We are going to get something from a. It is what, x square dou z by dou x the whole square, y square dou z by dou y the whole square plus 2xy dou z by dou x into dou z by dou y, right? We are getting this thing from this. And similarly here we are going y square dou z by dou x the whole square, x square dou z by dou y the whole square minus 2xy dou z by dou x dou z by dou y. This and this will cancel out automatically, and you can clearly make out 2 is coming out common. Sorry, 2 is coming out common. X square dou z by dou x the whole square plus twice y square into dou z by dou y the whole square. X square we can substitute as x square, we can substitute it like we have x square, 2 I can take common. First thing what we have to do is to get rid of, sorry, here it is not x square plus y square, it is y square plus x square, no 2, plus y square plus x square, there is no 2 term, it is x and it is y, so they will add on and give me x square plus y square, and this one will also give me x square plus y square. We know that x square plus y square is nothing but x square plus y square is nothing but e power u, 2 e power u. So 2 e power u will be it is y square plus x square, and this is, let me see, we are doing any mistake or what, because it was negative, this one will be positive, this one will be positive, and this one is minus y dou z by dou x. We can write this as e power 2u cos square v plus sin e power 2u sin square v into dou z by dou x the whole square plus e power 2u cos square v plus e power 2u sin square v. This is nothing but dou z by dou y the whole square. E power 2u is coming out common, and we are left with what, dou z by dou x the whole square plus dou z by dou y the whole square. Just one thing is missing, that why we are not getting e power 2u minus 2u. Let me check. So let me check. We want to prove this equal. Okay, but why we need e power 2y? Because we did it, and we should multiply by e power minus 2u here, and then we will get this, because in proof we will take this thing and substitute the values and convert it into this, but we didn't multiply it by e power minus 2u. So multiplying throughout by e power minus 2u, which gives me e power minus 2u. Finally you can see this thing is becoming perfectly similar, that is dou z by dou v the whole square, which will be, this will become 0, and finally we will be left with dou z by dou x the whole square plus dou z by dou y the whole square. So we are done with the second one, hence proved. I will now let's take some new question. So hope you have understood each and every step of this question. I tried my best. Okay, it has 2 proofs. I know it's lengthy, but engineering questions are like that only. They are lengthy, but they are worth solving, because they increases the confidence level by high level. Okay, by high amount. Now let's take the next question, which is this question. The question says, if z equals to f of x comma y, where x is equals to r cos theta, y equals to r sin theta, show that dou z by dou x the whole square into plus dou z by dou y the whole square equals to dou z by dou r the whole square plus 1 by r square dou z by dou theta the whole square. We have to analyze the function. Z is a function of x, function of y, x is a function of r, is a function of theta, y is a function of r, is a function of theta. Z equals to f of x comma y, x is equals to r cos theta, y equals to r sin theta. What we are going to do, write it as 1. We have to represent this graph, which will be r comma theta. So what we are going to do in the next step, what we are going to do, by chain rule, we will try to get dou z by dou r and dou z by dou theta. By chain rule, dou z by dou r is nothing but dou z by dou x into dou x by dou r plus dou z by dou y into dou y by dou r. Dou x by dou r is what? Dou x by dou r is nothing but cos theta, but we have to mention this since we are doing it first time. Which is nothing but cos theta. Dou y by dou r is nothing but dou by dou r into r sin theta, which is sin theta. Dou z by dou x is cos theta. Dou z by dou y is sin theta. Right? What we can do here, we are getting this value. Just keep it for the timing now as it is. We will see what we can do in the next. Dou z by dou x by dou r was this. We substituted, we are getting something like this. We are keeping it as it is for the timing, which is dou z by, okay, we need dou z by dou r square. So this is dou z by dou square. So squaring both sides. What we get? Dou z by dou r the whole square, which will be dou z by dou x the whole square into cos square theta plus dou z by dou y the whole square sin square theta plus 2 dou z into dou z by dou y sin theta into cos theta. We got these two things. Now we got this thing dou z by dou r, call it some a. Further on, what we can do is by chain rule, similarly, okay, we will see here, similarly dou z by dou theta the whole square is nothing but dou z by dou x into dou x by dou theta plus dou z by dou y into dou y by dou theta, which will be what? Which will be nothing but if you differentiate, I am going to get r minus sin theta plus minus sin theta. What we are going to get here? R cos theta. Now let's square this and see what we are getting. Okay, I'm doing it here, squaring both this side. We get, so what we are going to get is dou z. Okay, I directly wrote this value. We should get dou z by dou theta. Now we are going to get dou z by dou theta the whole square, which will be nothing but dou z by dou x the whole square r square sin square theta plus dou z by dou y into r square cos square theta plus 2 dou z by dou x into dou z by dou y r square sin theta into cos theta. Right? Now what we are going to do? Divide throughout by r square. What we are going to get? 1 by r square into dou z by dou theta the whole square is nothing but dou z by dou x the whole square sin square theta dou z by dou y the whole square cos square theta. 2 r square will cancel out dou z by dou x into dou z by dou y sin theta into cos theta. So what we are going to do, we are going to call it as B. Add A and B. If I add A and B, what I am going to get is dou z by dou r the whole square plus 1 by r square dou z by dou theta the whole square, which is okay. Now here I am not going to write the whole thing, you have to understand this. What you can understand from here, dou z by dou x the whole square is there, cos square theta is there, here it is sin square theta, so it will become 1. So I know dou z by dou x the whole square is for sure left. This thing and this thing here it was plus, okay, here it was minus r sin theta, right? It is minus r sin theta, so here this will be negative, we forgot to mention this will be negative. So this and this and this will cancel out, this and this will cancel out. What we are going to get, and here this part and this part will again become 1, and I will be left with dou z by dou y the whole square. So you can observe now we have got this proof also, so hence we are going to mention hence proved. Now I am going to again mention that whenever you do small properties, use small properties of trigonometry, mention it in the reason. Okay, I am not doing because the time duration of the lecture will increase, and these small things you should do on your own self. Okay, reason stuff. Okay, doing this thing is also a tough job itself. Okay, so with that said, we are done with this session. Please revise all these questions, solve it again, so that you can secure good marks in your mathematics examination of engineering. Thank you.